8C, theoretical probability. In this chapter, you'll learn about identifying equally likely events and also the probability of these events. Now, theoretical probability is about what you think the chances are. It's a very educated, intelligent guess based on information. So, to move forward, we need to understand the term equally likely, which means equal chance. So in example number 1, this dice has 6 sides. The shape is a cube. Everything is the same size. Me rolling a 1 has an equal chance of rolling a 2, a 3, a 4, a 5, and a 6 because it's equal. It's all fair. The dice is normal. There's no weird weight on it. There's no magnets. It's a normal dice. In number 2, this spinner is split up into 5 sections, and all the sections are equal. So if I spun the little black arrow around, I have an equal chance of landing on any color. However, in example 3, this is a spinner that demonstrates non-equal chances. It is not equally likely that I will hit red as I will hit blue, because if I spun the spinner, obviously I have a bigger chance of getting red and less of a chance of getting blue because blue is so small. So it's not equally likely. And theoretical probability is based on what we know about these things. So I would predict that example 1 and 2, I have equal chances, whereas in number 3, nope, I don't have equal chances, but I definitely would probably get a better chance of spinning a red. Okay, so let's identify events that are equally likely. Fair. So that's another way to think about it. Fair. Which of the following situations have equally likely outcomes? A. Randomly picking a boy in class where there are 5 girls and 5 boys. B. Rolling a dice and getting a number smaller than 2. C. Rolling a dice and getting an even number. D. Randomly picking a piece of chocolate in a jar with 4 chocolate candies, 4 peppermint candies, and 4 sour candies. Then E. Looking in the jar and picking out a piece of chocolate. Which one is fair, equally likely? At this time, pause and decide which ones. Okay, so chances are equally likely when everything is fair. So in A, the chances of me picking a boy in a class where there's 5 girls and 5 boys, well, the boys, it's 5 out of 10 people, as the girls are 5 out of 10 people. So it's equally likely that I'm going to pick a boy as much as I will pick a girl. It's equal chance. Rolling a dice and getting a number smaller than 2. So let's think about it. How many numbers are smaller than 2? On a dice, there's only 1 number out of the 6, right? Numbers that are 2 and bigger, there's 5 out of 6. Is that fair? No, that's not fair. Rolling a dice and getting an even number. Well, there's 2, 4, 6. There's 3 numbers out of 6. And an odd number, there's 3 out of 6. So is that equally likely of getting an even number and an odd number? Yes. Randomly picking a piece of chocolate in a jar with 4 chocolates, 4 peppermints, and 4 sour candies. Well, everything has a fair chance because it's 4, 4, 4, and I'm randomly reaching in, so everything has a fair chance. So yes, that is equally likely. Now, however, if you're peeking inside and you're looking in the jar and you can really spot where that chocolate is that fair? I mean, you can just really target that chocolate and just reach it and grab it, right? So no, that is not equally likely because you're looking. It's too easy to get the chocolate. Okay, skill 2, find the probability of equally likely events. It's important to understand to find probability, it's basically your likely outcomes, meaning what you desire, over the total opportunities. So if we're always talking about dice, it's always out of 6. If we have a 10 color spinner, it's out of 10, and so forth. Okay, so if you roll an ordinary dice, what is the probability of getting a score of 5? So on the dice, you roll it, there's only one 5, it's 1 out of 6. And if you want to get fancy with this, 1/6 is always 16.6% or 0.16 reoccurring because it keeps going. The 6 doesn't stop moving. So this time, pause and do B, C, D, E. Okay, so if you roll a dice, the probability of getting an even number, well, there's the numbers 2, 4, 6, and 8. Sorry, no 8. So it's 3 out of 6, which is 50%, because it's 1/2, which is 0.5. It's an equal chance. A prime number. Prime numbers are always 1 times itself. It cannot be a number with more factors than 1 and itself. So for example, 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime. But 9 is not prime because you could do 3 times 3 or 9 times 1. 12 is not prime because you can do 1 times 12, 2 times 6, 3 times 4. 35 is not prime because you can do 1 times 35, 5 times 7. Whereas the prime numbers are only 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11. It's only 1 and itself. So on the dice, we have the numbers 2, 3, not 4, 5, not 6. So it's also 3 out of 6, which is 50%, which is 0.5. And 1 is not prime because 1 is 1 times 1, and it's already 1 times itself, which is just 1, so it cannot be prime. A factor of 12, meaning numbers that multiply to make 12, that's 1, 2, 3, 4, not 5, 6, 5 out of 6. Hey, and if you know that 1/6 is 16.6, that means 5/6 is 5 times bigger than that. So you have to do 16.6 times 5 to get the answer. And I'll let you do that to get fancy. But you can also leave your answer as a fraction. I will accept that. Then finally, a number bigger than 2. So bigger than 2, not including 2. 3, 4, 5, 6. 4 out of 6. Which, by the way, makes 2/3 because you can divide by 2. And that, by the way, is 66.6% or 0.666 recurring. And that's it.